Hello, I am Yasin Yenaydın, and today I'm going to present deep convolutional neural network and multilayer perceptron on CIFAR-10 dataset for classification purposes. And this is my layout, and I'll start with a small introduction part. After that, I'll try to explain the dataset. Then I'll give the architecture of deep convolutional neural network and multilayer perceptron, and at the end, I'll explain the experimental results together with conclusions and also the future work. In this study, different objects are recognized in the images with the assumption that there exists only one type of object in the images, and it's a very complicated task since different objects can exist in different conditions in the images, such as, for example, the images can be captured in foggy and rainy weather, and also in different daytimes, like in the morning and at night. And also the objects can be in different orientations and also in different locations in the images, and so on. The CIFAR-10 dataset includes 60,000 RGB images with the size 3 by 32 by 32, and 50,000 of them are training images and 10,000 of them are test images. Some of the examples are given on the right, and these images are very blurry, as can be seen. And the dataset includes 10 different classes, which are car, ship, frog, deer, cat, dog, plane, truck, bird, and horse. As for the architecture of deep convolutional neural network, 5 convolutional layers are utilized together with 3 fully connected layers. In each of the convolutional layers, ruler activation function is utilized to diminish the vanishing gradient problem and also the overfitting problem. And each of the convolutional layers 3 by 3 kernel size are utilized with appropriate depth size. And also in the first, second, and also in the 5th convolutional layers, the max pooling operation are performed to decrease the image and to get the abstraction of the image. And in the fully connected layers, the real activation function is utilized for the first 2 fully connected layers as for the same purposes, and also the dropout is utilized before the fully connected layers to reduce the overfitting problem. And at the end, we have 10 neurons to get to estimate the one of the classes. As for the multilayer perceptron, 5 fully connected layers are utilized in the first 4 fully connected layers, and the ReLU activation function are utilized as for the same purposes again. And at the end, we have 10 neurons to predict one of the classes again. And also softmax layer at the end of both DCNN and MLP are utilized, and the softmax the formulation is given for prediction at the softmax layer. As for the experimental results, K-mean and Xavier initialization methods are utilized, and their standard deviations are given here. As for the loss function, in the training phase, the cross entropy loss function is utilized, and the formulation is given here at the bottom. The Adam optimizer is performed. The mini batch size is chosen as 2 and 56. The epoch number is chosen as 10, and the number of trainable parameters are given here for DCNN and also multilayer perceptron. The accuracy results are given on the right, and we can see that DCNN is superior to MLP with these parameters. And also the confusion matrices are obtained for deep CNN on also multilayer perceptron. And on the right, we see the confusion matrix for deep CNN. And we have a good prediction for frog object and also plane and also car objects in the images, but we have relatively bad estimate for cat in this network, in this trained network. And also the confusion metrics for the multilayer perceptron are given on the right. And we have good results for plane and also ship, but we have bad results for bird, cat, and deer in terms of accuracy with this trained network for multilayer perceptron. And to conclude, deep CNN is superior to multilayer perceptron in terms of accuracy, and deep CNN utilize convolutional and fully connected layers. However, multilayer perceptron only utilize fully connected layers, and because of these facts, the MLP relates unrelated pixels for classifications and might relate the unrelated pixels for classification. However, deep CNN relates the pixels in the close vicinity through 2D kernels, and also the 2D kernels are translation invariant, and because of these reasons, deep CNNs are translation invariant, and they might utilize less trainable data to extract the same features. And in the future work, it is aimed at object detection built on the deep CNN, since it extracts important features of the objects at the first convolutional layers. Thanks for listening.